Okay, so welcome to DataStream's Dive into Data webinar series. Today's webinar is going to be Excel tips and tricks for working with water quality data. And I know that everyone was probably expecting to see Patrick, our data specialist, running the webinar today. However, Patrick got pulled away from work last minute, so he wasn't able to be here, and so I'm stepping in for him. And I know that many of you probably don't recognize me. I'm actually the newest member of the DataStream team with the Gordon Foundation. My name is Mary Kruk, and I'm the new water data specialist. I have a background in water quality assessment, and I'm based in Calgary, and I'm really excited to be joining the DataStream team. So I'm going to do my best to answer the questions you have today about the presentation, but if there's any questions that I'm not able to answer, I'll just bring the questions back to the rest of the DataStream team and they can help me answer, and then I can get back to you via email. And also just bear with me if there's some bloopers along the way while we're testing out all the Excel tricks that Patrick wanted us to cover today. Just a note about questions during the presentation. If you have a question that's related to the presentation material, you can just open up the Q&A box, which should be accessed through a button on the bottom of your Zoom screen. So you can just type your questions into the Q&A box and I will answer your questions. Since we have so much material to cover today, I'm going to most likely wait till the end of the presentation to answer the Q&A. However, if you're having any technical difficulties during the presentation at all, you can type any questions into the chat box and my DataStream co-hosts can help you troubleshoot from there. All right, so I'll just give you a bit of background about DataStream. So DataStream is an initiative led by the Gordon Foundation, a 55-year-old charitable organization that's based in Toronto. And it's 3 regional partners: the Northwest Territories Government, the Atlantic Water Network, and the Lake Winnipeg Foundation. DataStream is an open access platform for sharing water quality data, and it's free for everyone to use. So that means that users can visualize and download water quality data that's collected by community groups, Indigenous nations, researchers, and governments. And DataStream split into 3 regional hubs right now across the Mackenzie River Basin, the Lake Winnipeg watershed, and across Atlantic Canada. As you can see, DataStream only kicked off in 2016 and it's rapidly growing. Right now we're eyeing up pan-Canadian expansion at some point and bringing in a Great Lakes DataStream hub in the near future. And a bit about our Dive into Data webinar series. This webinar series was kicked off to promote and share data management best practices, mostly as it relates to water quality data. So more and more large data sets are moving to open data licenses. Many of the provincial, territorial, and federal government data sets are now becoming open. So we thought it would be best to increase data management practices, teach better data management practices to support better quality science and evidence-based decision-making among our users. And this Excel tips and tricks webinar is adapted from part of a data management workshop that Patrick gave in person. This was in collaboration with one of our regional partners, the Atlantic Water Network. So the material was originally developed for in-person workshop. So we've done our best to adapt this to a webinar format. Like I said, there's going to be a lot of material we're covering today within a 1-hour time frame. And you'll see that there's going to be a lot of extra slides included in the presentation. And these are just for you to use as reference. So if you don't have time to run through all the exercises and examples that we cover today, you can use these slides to work through the references and exercises in your own time. And here's an overview of some of the topics we're going to be covering. All these topics we're going to be covering with the use of the long and the wide data sets. You should have received them via email yesterday. However, if you don't have them open or you don't have them handy right now, there should be a link now in the chat box to datastream.org webinar page, and you can open that web link and download the data sets there. So having those data sets open, as well as a PDF of the presentation slides will be helpful throughout the presentation. All the material we're covering was developed for Excel using a Windows or PC computer. So if you're on a Mac, Excel does have all the same functions. However, the buttons may be in slightly different spots. And I'll just go over the two types of dataset formats that we'll be using today. So first is the wide dataset. This is a really common format for water quality datasets. So in the wide format, each water quality characteristic or parameter has its own column, and then each row indicates a single sample. This format is best used when you want to perform graphing functions in Excel or any other types of functions within an Excel spreadsheet. So this is a format that I think a lot of people are used to seeing. The next format is the long data set, which I'll pull up here. So the long format is a common machine readable format. And by machine readable, I mean a format that computers will often be able to take data in this format. So this format is what DataStream uses when you're uploading data. This is also a common format if you're using other computer software, like if you're using R to compute statistics, you would most likely read in your data in this long format. It has characteristics or water quality parameters in a single column, and then the result values in a single column as well. So each row of a data set indicates a single observation of a water quality parameter. It allows for more information to be related to a single observation, like whether a parameter is in a dissolved or total fraction, or whether the parameter is below a detection limit. All right, so bring back up the presentation again. And with that, I think we're just going to dive right into the material. So the first topic we're going to cover is number formatting. And this is just formatting values within the cells. The most common use of number formatting is typically when people have issues switching between dates and time formats in Excel. Sometimes it gets read in an incorrect format. And then sometimes, you want to change the number of decimal places if your cells are in a number format. So we're just going to go through that. So there's going to be these slides inserted, as I said, that have a step-by-step on how to perform some of these functions. I'm not going to focus on those. I'm mostly going to focus on the examples within the Excel data sheets. So for number formatting, first we're going to open up our long data set. And the first thing we're going to practice is formatting our date column. So just a note about Excel dates, Excel will automatically format a date into the same format that your computer is preset to. And so to know the format that your computer is preset to, all you have to do is look in the bottom right-hand corner. This is on a Windows or PC. And however your date and time is set up is how Excel will automatically format. So on my computer, and for the format that's commonly read in for a lot of programs, like if you want to read your data into DataStream, we format our dates into a year, month, date format with dashes in between, and then we also go on a 24-hour clock. Okay, so for this example, we want to change this date format that's in a year, month, date to instead month, day, year with slashes in between. So in order to do that, we're going to highlight the column that we want to format. You can open up a formatting window. The quick button is Control 1, and that brings up the Format Cells window. You hit the category that you want to format to. So we are interested in formatting into a date format. And then there's a list of preset options for dates. So none of these are the exact format that we're looking for. None of them have the backslashes inserted in between. So we want to create our own date format. And you can do that by actually going down to the custom category. So now that we're in a custom category, in this bar here, you can just type in exactly the format that you want your date to be in. So we want ours to be month, day, and year with backslashes in between. And when you type in your custom format, you don't have to worry about any of the preset date formats being erased or overwritten. Those are always going to be there. So we've created our new date format, press OK, and that's how you would format into a different new date format. If you want to format numbers, for example, you want to change the number of decimal places in your latitude or longitude, you would just select that column. Another way to access the format window is just to right-click on your column and then hit Format Cells. So this brings up your same format window. This time we're interested in formatting a number category, and here you can just adjust your number of decimal places. So we just want to change this to 2 decimal places, and there you go. I also want to cover using converting between text and date formats, because that's something really common that you might want to do in some of your analyses. Or sometimes Excel will read in a date incorrectly and think it's text, and you want it to be in a date format so you can properly plot it on a time series graph. So we're going to go through an example like that. So this is in a date format. If we wanted to convert this into text, we could open up the format window and then just hit text and press OK. But what we see here is this doesn't actually give us what we want. It converts the date into this string of numbers that's not really easy to interpret. This is because this is how Excel actually stores dates in its system. It stores it as a string of numbers. So that is not the format that we actually want to do. We want to convert the date as a text string without actually messing up the way that it looks. So we can just undo this. If you want to undo any action when you're playing around in Excel, you can just hit the undo button up on the top left, or you can hit Control-Z. So instead, there's another way to format between text and date formats. That's by going to the Data tab, and then within the Data tab, you're going to click this Text to Columns button. So this is used to convert between the text format and other formats. We're going to use the preset data types that it has in here, so delimited. It gives you a preview of what your data looks like when you have these selections chosen. We're going to turn off all the pre-selected delimiter tabs. So it's reading in our dates like this right now, which is the correct date format. And if we want to convert it to text, we just click text and here and hit finish. And now it's formatted as a text while still displaying the correct date. So sometimes your data will actually get read in this way to Excel, depending on what kind of file you're opening. But you want it, so now we want to try to convert it back into a date format because that's a more usable format for analysis. So we're going to use the text to columns button to convert it back into a date. We'll have the same selections that we chose before. And then in step 3, we're going to actually now select date because we want it to go back into a date format. And then there's a drop-down list beside date that's going to indicate the different ways you can format your date. So the order of the year, month, and day. You want this year, month, and day order to match the order that you see the date in. So we want our format to be year, month, day. So it's already pre-selected. However, if your date looked like month, day, year, you could switch that. And then we hit OK. And now it's back into a date format again. Yeah, so those are some really handy formatting tricks if you are working with some dates and some number formats in your spreadsheet. And that's what's indicated in these exercises here. So you can go back and look at these later if you like. The next topic we want to cover is conditional formatting. So conditional formatting, it just means that it applies formatting to cells that you highlight based on rules you set and then whatever values are in the cells. So you can highlight your cells different colors to highlight outliers in your data or cells that don't meet a certain criteria. You can create gradients of colors to look at like highest to lowest in a certain water quality parameter. And then once you have conditional formatting set with different colors, you can actually filter your columns based on color. So I can show you that as well. So here's an example of what conditional formatting looks like. In this case, we have some conditional formatting on the pH column. So any pH values less than 6, we've highlighted it red. And there's some instructions on how to do this on your own. We're going to start with the wide data set for our examples. Okay, so within our wide data set, we want to highlight pH values that fall outside of the CCME guideline. So the CCME guideline range is 6.5 to 9. So if the pH is outside of that range, we want to highlight the cell red. If it's within the range, we want to highlight it green. Okay, so we're going to find our pH column here in the wide data set. We're going to select the cell that we want to apply formatting to, and then hit the conditional formatting button, which is up on the Home tab. So under conditional formatting, there's different categories of rules that you can choose. You can highlight your cell based on numbers that are greater than, less than, and between. You can do highlighting based on statistics as well, like based on averages or percentages. For this example, we're going to go into the highlight cell rules. And then first we want to select highlight cells between. So we want to highlight the cells between 6.5 and 9 green, because those are going to be within CCME guidelines. Hit OK. So that automatically highlights all the cells here that are in those guidelines. And if we want to now select highlight the cells that are outside of the guidelines, we'll go back into conditional formatting and the highlight cell rules. There's no preset here for values that are outside of a certain range. So in that case, we're just going to hit the More Rules button, and we get this new formatting rule window that pops up. There's different rule types that you can select. For this one, we're going to use format only cells that contain. So what we want to do is we want the cell values that are not between, and then we put in 6.5 and 9 again. And then here you actually have to select your formatting that you want to apply. If you don't select anything, nothing will happen. I've made that mistake many times. So we want to fill the ones outside the guideline red. Hit OK. And then, all right. Oh. So that ended up highlighting all the cells. We want to go back in. Cells not between 6.5 and 9. Red. And okay, there we go. So now everything outside 6.5 and 9 is red, but that's also including the column header and also the blank cells. So if you want to remove the formatting from the column header, you just click on that cell. And then under conditional formatting, you can go clear rules and then clear the rule from that selected cell. If you want to remove the conditional formatting from all the blank cells, you select that column again. We're going to go to new rule. This is the same, accessing more rules and new rule. It brings up the same new formatting rule window. We're going to go back to cells that contain. Instead of cell value, we're going to say format only cells with blanks. And then under where format, even though we want to revert it back to blank, you actually have to go in and hit no color and then OK for it to remove the formatting on the blanks. Okay, our next example is we want to format the dissolved oxygen column where pH is less than 9 and conductivity is less than 100. So we're going to go over to our dissolved oxygen column. So this is formatting of this column based on values in different columns. We're going to highlight the column that we want to format, and then we're going to go right to the new rule button, because ones that are based on other columns don't really have any presets here. So we're going to hit new rule. And this time, because we're formatting based on values in other columns, we're going to select the rule type of a formula. So use a formula to determine which cells to format. So we're going to type into the formula bar. You always start with equals, where pH is less than 9. So we're going to click on our pH cell. Oh, sorry, you have to go hit this up arrow to bring it back to the sheet. And you hit your pH column. Automatically, it will select the cell with these $ values beside it. All that means is that it's going to, the formula is going to be based on that fixed cell, so it's not going to move. We don't want that. What we want is for the formula to change relative to which position, which number we're looking at in the dissolved oxygen column. So shortcut to remove the $ is to keep pressing F4 until the $ are removed, or you can actually just manually delete the $. Either works. So now we have the pH column less than 9. Oh, and since we have 2 rules that we're applying, I forgot, but I need to add in an AND function. So anytime you want to apply 2 different conditions, you need to use it inside of this AND function. So you put and then inside the brackets, you do your condition 1 and then comma and then your condition 2. So our second condition is the conductivity less than 100. And then we are going to choose a formatting color. So I'm going to fill that yellow. All right, and then we hit OK. And then all of our dissolved oxygen cells are formatted based on conductivity and pH. And here's a number of other formatting exercises that you guys can practice if you're interested in learning a bit more. Okay, the next category we're going to be covering is filtering. So filtering allows you to basically create subsets of your data. You apply a filter on the column headers, and then this narrows down your data to include only what you want to see. So it's handy if you want to look at only a certain time range in your data set, if you want to only look at certain characteristics, if you want to create a subset of data to make a graph or to run statistics on. And then it's also handy if you want to identify outliers or incorrect data points. Here's an example of what the filter headers look like when you have them applied. So there's going to be a drop-down button beside each of our column headers, and then from there you can click on the different filters that you want to apply. Some instructions. Okay, so for this example, we're going to start with our long data set again. All right, so we want all dissolved oxygen values sampled in 2017. So to start, what you want to do is you want to click the top left-hand cell in your data sheet, and then you want to hit Control A. Control A just selects the whole data sheet. So you just want to make sure that all the data that is in your data sheet is being filtered on. Okay, so once you have everything selected, you go to the Home tab, and then from Home, you can click Sort and Filter, and then you hit the Filter tab. So now there's filters applied to each of your columns in your data set. We want dissolved oxygen values from 2017. So in our long data set, we would go over to our characteristic column, so our parameter name column, and you hit the drop down. So the drop down will show you a list of all the values that are in that column. But we're just interested in dissolved oxygen. There's a couple ways you can do it. You can just, you can unselect all the characteristics and then go down and find the characteristic you're interested in and highlight it or check the box. Or else you can use the search bar. So you can just type in what you're looking for, dissolved oxygen. and hit OK. And now it's just giving you dissolved oxygen values. And then for the date column, if your date column is formatted as a date, as we were practicing earlier, so it's in date format, it's going to give you the dates like this. So it's going to show you all the years. So you could just highlight the certain year that you want to look at. Or if you wanted to get more granular, you can hit the plus sign beside the date, and then it'll show you the months in that year and also the days that are in that, the days that have data in that year. And then so you can select exactly which date times you want. We're just interested in 2017 data, so we're hitting OK. So there we go. We have a subset of our data from 2017 dissolved oxygen values. To clear any filters that you've applied in your data set, you just go back to your sort and filter button and you hit clear. And that resets it to the whole data set again. Our second example is we want average pH values at site 3 for 2008. So again, we'll start with our characteristics. We'll search pH. You hit this to unselect all, and then you just hit the characteristic you're interested in. And we want 2008 as our date. And site 3. So our monitoring locations, site 3. There we go. All right, so we have our values for pH in this subset, and we want to calculate an average. So here I would just go to the bottom of the column that I'm interested in, and then you can type in a formula to calculate average. So you just type average and select the cells that you're interested in. So that gives us a value of 33, which is completely unrealistic because pH only goes up to 14. And we can see here that our values are between 4 and 6. So this seems a little strange, right? Well, this is because when you apply filtering on your data sheet, what it's actually doing when you type in a formula is it's using all the cells that are between these rows in the data sheet. Even though they're hidden, it's including everything between this row and this row in the calculation, which isn't what you want. And we wanted to choose this example because it shows really obviously that that's a mistake. But if you're working with a huge data set and making calculations, and all your values are really within like a small range, you might not really even notice that that's not the right number. So there is a way around this. What you have to do is basically copy your subset of data into a new sheet. So you hit Control A to select everything, Control C to copy it. You open your new data sheet, and then Control V will paste. You can also do all these functions by right-clicking and hitting copy and paste as well. So now we have it in a new sheet, we can actually calculate the true average of the cells. So if we apply this formula again, we get a true average of 4.5 or 5.4. There we go. Okay, and one more example using the wide data set. Okay, so same thing, we're going to apply filter to the whole data sheet. So Control A and turn on our filters. And we want water temperature data greater than 10. So we're going to go over to our temperature, and we're going to hit the drop down. It would be pretty labor intensive to go through this list and select every value that's greater than 10. Yeah, you'll be clicking for quite a while, but I mean, that's one way. But the other way you can do it is using this number filters column. So under number filters, you can actually choose a lot of automatic filters like greater than, less than, between, same as in conditional formatting. So if we want greater than 10, we can just go greater than 10 and it will filter that for us. So that's pretty handy. And like I mentioned before, you can also filter based on your conditional formatting colors. So since we have pH with some conditional formatting, under your drop down and for your filter, you can actually go filter by color, and you can choose one of the colors that you filtered to, and that's another way to utilize some of the conditional formatting. So you can go select all to undo that, or you can just hit clear if you want to clear all formatting. Great. Okay, back to our presentation. So we've covered our 3 examples for that. They're are a few more exercises if you want to practice this on your own time. But next we're going to move on to removing duplicates. So this is a pretty handy feature for a lot of people because sometimes you have a really large data set that has duplicate rows and you can't find them on their own, but you want to be able to remove them. So you can do that in Excel. You can also use the removing duplicate function to determine the number of unique locations in your data set, determine the number of unique characteristics, or anything like that where you want to just find the unique count within a data set. So this is what it looks like if from our long data set, we were to remove all the duplicates and just leave the unique monitoring locations remaining. So it's gotten rid of all the data except for unique site number or site names. Some instructions. So there's two different ways to remove duplicates using Excel, and I'm going to show you both. There's a remove duplicates button, and then there's also an advanced filter button. So we're going to start with long data set again. I'm just going to clear my formatting or filtering on there. I'm also going to remove the filter tab for now, just so that we're only using one function at a time. So the first thing we want to do in the long data set is show the unique characteristics. So we start from going over to our data tab, and we want only unique characteristics in the data set. This function, I'm going to start by using the remove duplicates button. This is the preferred method. I like this method a little bit better, and I'll show you why in just a second, but both work equally well. So if you hit the remove duplicates button under the data tab, it'll bring up your whole data set and call on all the column names in your data set, and they're already all pre-selected. If we want just the unique characteristics in the data set, what we can do is unselect all the columns, just select our characteristic names, and then hit OK. And then a pop-up window is going to come up. It's going to tell you how many duplicates it found in the data set and how many unique values remain. So using the remove duplicates button, this disclaimer pops up and shows you exactly how much it's removed. When you use the advanced filter button, as I'm going to show you next, it doesn't give you this pop-up. So that's just one of the reasons why I like this one a little bit better, but it's total preference. So now what it's done is it's only left us rows that have the unique characteristic name, and we can see we have 52 of them, as the pop-up window told us, and you can also see in your bottom right here. So we have 52 unique characteristics. When you use remove duplicates, either of these functions, it actually does remove that data from your data set, so it's not there anymore. So you might, if you're doing this, but you want to maintain your original data, you might want to save this as a new data set just to make sure that you don't lose any data that you didn't mean to. And in our case, because we want to do a bunch of other examples, we're just going to undo this. So I'm going to hit Control Z. Once again, you could just go undo up here. So that brings back all of our data. Okay, so the next example that we want to do is remove any duplicates from the data set. So any duplicate rows at all. So this one I will show you using the advanced filter button. So under data, we're going to hit the advanced filter button. The list range, this is important. This is the number of cells that it's filtering on. Since we want to remove duplicates in the whole data set, we want it to include all the cells. So it is including all the cells here. You can see there's this flashing dotted boundary, and it's going to go around our whole data set. So it's good. We have our whole data set selected, and we want it to tell it to filter on unique records only, and then we hit OK. So what it did here is it actually did remove, I think, 3 duplicate rows, but that pop-up button doesn't come up to tell you that. But it does work the same way. If you wanted to just use the advanced filter button and only filter on one column, you could just hit this arrow and then select the columns that you want to filter on, and then apply unique records only and do it that way. But I'll just show you, if we were to do it using the remove duplicates button, you would keep all of them selected, all the columns, hit OK, and I think I had already removed. And sorry, here's the bloopers I was telling you about. We'll just make sure that I'm starting from scratch and that I'm not missing any data here. Okay, so from the remove duplicates button, you want to make sure all your columns are selected and remove duplicates. And yeah, it tells you that 3 were removed and over 12,000 remain. So I'll just hit undo again. Using the Y dataset, we'll do one more example. In the Y dataset, we want only unique monitoring locations. I'm just going to turn off the filter here. So only unique monitoring locations. So this is a good example because it brings up the point that within a data set, you're often going to have more than one column that defines where a data point is located. So in this data set, we have monitoring location ID. We also have a name and a latitude and a longitude. And what we want to really focus on is that all 4 of these columns define where a data point is located, because what often can happen, especially with a long historical data set, is over time, a site may have the same location, so the same lat and longitude, but the site name may change, or vice versa. The site name may stay the same over time, but the actual location may shift. So if we wanted to determine the number of unique locations in this data set, what we'll do is go over to data and we'll use our remove duplicates button. We'll unselect it, everything, and then we're only going to choose the monitoring location columns, so the first 4, and we hit OK. It's telling us we have 9 unique columns, or sorry, 9 unique monitoring locations. So what we can see is we have sites 1 through 8, but site 4 actually did change its location over time. So this remove duplicate function can help you identify things like that in your data. All right. There's some more exercises for you, but we're going to move on to creating graphs. So graphing is really great for quick interpretations of your data. Being able to visualize your data is super handy to look at the way that characteristics change over time, to compare 2 characteristics, multiple locations. You can add trend lines, or you can look at just to look if there's incorrect data in your graph. Like if you're graphing temperature and one is just like totally like 300 degrees, you might think that's possibly a mistake. So graphing is just a quick and easy way to identify things like that. And there's many different graphs that you can create in Excel. We're not going to have time to cover many of them. I'm just going to go over a really simple line graph with you, but then you can play around more. And I'm sure many of you have already created graphs in Excel, but we're just going to cover the basics here. So this is an example of what a simple line graph would look like. And then using our wide data set, we're going to recreate this graph right here. So we're going to graph dissolved oxygen and water temperature at site 3. And I just want to make a note that in Excel, like I mentioned before, using a wide data set, so with the characteristics as column names, is the only way to use the graphing function in Excel, unless you're to convert your long to a wide format. Okay, so I'm going to go into our wide format to create this. So we want to graph dissolved oxygen. So what we're going to do is highlight the columns of interest. We have dissolved oxygen and water temperature, which is over here. You're going to hit Control when you're selecting multiple columns. So I'm pre-selecting the columns that I want to graph. And then we want those 2 parameters graphed over time. So I'm going to select our date column. So once I have 3 my columns selected that I want to graph, I go to the Insert tab, and there's a chart box here that gives you a bunch of recommended charts or just commonly used charts right in the window. and we're going to use a line chart, but there's many different charts that you can use. So I just wanted to show you, if you click this pop out, first of all, it will recommend, based on the data you've selected, it will recommend a chart type for you. And then if you go to the All Charts tab, you can see a full list of all the different graphs that you can create in Excel. So we're going to create a line graph. And I'm going to do line with markers. In this case, I like using line with markers because it indicates where the actual data points lie. And then I'm going to hit OK. And here it automatically creates a graph with water temperature and dissolved oxygen over time. The reason why there's these data points are not connected is because there's blank cells in the data. If we were to filter the data to remove the blanks, then these would be connected. Oh, and I just realized that I did not filter this for site 3. So I will quickly do that for you just to show you how it's done. But we wanted to only use site 3, so we were going to apply our filter and then only select site 3 data. And then, like I said, if you're using a subset, you actually have to copy. If you're using a subset, you have to copy it into a new sheet. So now we're only working with site 3 data, and I'll select my columns again and insert. And here I could actually just go from the chart tab Yeah, we'll just give it a minute. All right, it pulled through. That's great. Okay, so we have our data for site 3. It's seeming to go really slow for me, but I'll just keep talking while it's doing its thinking. Within the chart, if you don't end up selecting the columns that you actually wanted in the first place, say you forgot to select a characteristic that you wanted to use, or you forgot to select date, you need to edit something. If you want to edit the data that it's graphing, you just click in the chart area, you right click, and you go to select data. And here you can add and remove your series that you're plotting. So you could add a new series, you can edit your x-axis, so it's editing time right now. And you could also change the names. Ooh, I may have to. Sorry guys, I might have to close and open my Excel file again because it's really not working for me. Okay, so there are ways to change the series headers and names in that select data tab. Also, once you incorporate a graph, you can also add and remove things like axis titles. I don't want to spend too much more time playing around with this, but yeah, maybe I will just move on to the next graph here. And if we want to cover any more simple graphing functions at the end, you guys have some questions, we can just go back to it because I just want to make sure that we cover the rest of our material here. And I think graphing is one of the functions that a lot of people have done before. So anyways, we were most of the way through getting to this graph. I would have just changed the legend headers here and maybe the title as well. But next we're going to move to pivot tables because these are really fun and super handy, and I actually learned quite a bit about pivot tables while I was running through this presentation, so it's great. Pivot tables allow data to be rearranged in many different ways and grouped, so you can do types of analysis on groups of the data and graphing using different groups on characteristics or years. So a really handy function using a pivot table is actually you can take a long format data set and transform it to a wide data set, and I'm going to go through that with you. You can also remove columns that aren't necessary. You can create summary tables with averages and mins and maxes, and you can summarize by location or year or characteristic, as well as make some graphs using those as well. So this is what a pivot table looks like. As you can see in this pivot table, it has the characteristics as the row names and then the sites as the columns, and then it's giving you an average per site and characteristic. But you can also switch it around. So this looks a little bit more like a wide format data set where the parameters are in the column headers, and then we have the site and the month in the rows, and it's giving you the maximum value per site and month. Right, so we'll just dive in and do an example in the long data set. All right, so we want average pH by monitoring location name. So to create a pivot table, you're going to select all your data. You're going to go to Insert and hit Pivot Table. You want to make sure the whole data set's highlighted here, so that's good. And we're putting it in a new worksheet so we can start clean. So this is what an empty pivot table looks like. It doesn't have any data in it right now, but it creates a list of all the columns in your pivot table formatting window. And then what you can do is drag the column names into the 4 fields below. So if we want average pH by monitoring location, what we can do is we can take the monitoring location name and we're going to drag it into our rows. So now it's created in the rows. We're going to take our characteristic name and put it into columns. And then now it's a table that's laid out like our wide format, but there's no data inside of it. So we have to tell it what values to use as the data. So we want the result values, and we're going to put that in the value tab. And what it automatically defaults to is it gives you sums for these characteristics and sites, which isn't super handy when you're looking at water quality data. Often the sum of all the observations isn't of great interest. I think what's of more interest when you're looking at data is usually the averages or the maxes or the mins. So to change that under our values field, we just click on that field and then we hit value field settings. This box will pop up and you can choose what type of parameter you want to display. So we want it to display averages, and you hit OK. Now it has a table of averages. If we want to know pH, we just basically same thing as wide format. You'd scroll over to pH, and these are the average pH values per site. Another way you can do this a little bit of a cleaner view is instead of having the characteristics names in the columns, you can drag it over into the filters. And then what it's going to give you is at the top here, the column header is going to be a drop-down filter list of all your characteristics. And same as with the other filter function, you just search for the one you want, hit OK, and then it's going to give you just a single table with average pH values. If we want to do the max temperature per year regardless of location, what we would do is we would change the row value so we can remove monitoring locations, and instead we're going to put in the the activity start date in the rows. And what Excel will do in pivot tables is automatically group dates by year. And you can ungroup this, I'll show you a bit later. But so it'll give you automatically the years. You can choose temperature. And then instead of averages, we want to know maximums. So you just open your value field settings, hit max. And now this is a table of max temperatures per year across all locations. The third example would be minimum temperature by time of day for each location. So what we're going to do is keep it on temperature. We're going to change this to minimum. And we're going to do time of day and location. So I'm going to remove the date settings from our rows. And instead, I'm going to go media or monitoring location name in the rows and also activity start time in the rows. So it has by site, and then this is the times, but like I said, Excel will automatically group times and dates. So this is grouping it by the hour. So if we want to ungroup it and see the actual times in our data set, we'll click on the time, any of the time cells, you right click, and then you hit ungroup. And this is going to give you the actual times within each site and then the minimum temperature at each time of day at each site over the entire data set. So there's tons of different ways you can regroup your data using pivot tables. Those are just a few interesting examples. And the last thing I want to show you, last two things I want to show you, I promise, is you can convert a long data set to wide. So this is really handy. So if you want to graph or do statistics in your data, what you're going to do, there's a step-by-step instruction for this in the PowerPoint slides, but what you're going to do is include monitoring location, date, and time in your rows. So we have monitoring location, we have time, and we're also going to add date. And then we're going to have our characteristic names in columns. And then we're going to set our values to averages. Okay, so it's starting to look like our wide data set. We have to ungroup our dates and our times. So we'll select our date, right click, and hit ungroup. So now it's going to have all the dates and then the times that are in each date. We're going to go under pivot tables design. The layout box, we're going to switch some things off. So we're going to hit subtotals, do not show subtotals, turn grand totals off for rows and columns. Report layout, we're going to show in tabular form. So this is starting to look more like a spreadsheet. We're also going to repeat all the labels. And in the last box, blank rows, we're going to say remove blank line after each item. And now you have a wide data set converted from your long data set. So this is all your data values, time, date, and location. And you could add more fields in here if you wanted more in your rows. And you can actually save this file as a CSV if you wanted to save a copy in wide. And the last thing I'll show you now is just how to create a pivot chart. So using these tables, you can create charts with different groupings. We're going to create a chart that has site 1, 2, and 3, and then the average temperature and dissolved oxygen values per year at site 1, 2, and 3. So the x-axis is going to show us date and year, and then we're going to have dissolved oxygen here. Okay, so we're going to go back into our wide data set. Using this value, or so the table that we've created here, we're going to go to insert, and now we're insert, we'll go into the chart section, and this time we're going to hit pivot chart. And we're going to go back to line, the same line with markers graph that we used before. Hit OK. So what it is automatically going to do is it's going to plot a ton of data in your pivot chart. It's going to plot all your characteristics, all your times, all your dates for every site in your data. So we want to filter it. So within the pivot chart, you can filter, which is super handy. So under characteristic name, you can unselect all of them, and you can just select the ones that you want. So we want temperature, and we want dissolved oxygen. So we'll just go dissolved oxygen and temperature. Okay. Okay, so we have that, but it's still showing us all the sites, all the dates, all the times. So we can also filter the monitoring locations. I just want, just for the ease of viewing, we just want sites 1, 2, and 3. And we want to remove the granularity of time that it's displaying here. So using the plus and minus symbols in the bottom right of the chart, you can remove elements. So if I hit the minus sign, it'll get rid of the times. So it's just showing you by date and by site. However, we want it to group by year. So I'm going to go back into my pivot table, and I'm going to right click on the dates, and I'm going to hit group. So we're actually going to regroup it again, and we want it to group by years. And press OK. And now go back into our chart, hit minus, and now we have a pivot chart that is by year for dissolved oxygen and temperature, which is the same as our example. All right. And this is just some different exercises you can practice if you want to play around with pivot charts a little bit more. So yeah, we made it to the end of our webinar here. Thank you very much for bearing with me as I troubleshot and got through all the material. If you're interested in learning more about DataStream, you can check out our website, datastream.org. We're also on social media. You can send us an email at datastream@gordonfn.org, or if you want to send me an email in particular about some of the presentation material, my email is just mary@gordonfn.org. DataStream has a monthly newsletter. You can access the registry by clicking this link in the slides, or else from our homepage. There is a little button on each of the landing pages in the, I think, the bottom right that's leading to our webinars, or sorry, to our newsletters. So like I mentioned, this webinar was also recorded, and we post all of our webinars on our YouTube channel. Those can be accessed via our homepage. Same thing, if you go down to the bottom right of any of our home pages, you'll see a little YouTube button, and it'll lead to our YouTube channel where you can see recordings of all of our webinars we've done. Just to share a bit more about upcoming webinars, later on this month, Patrick, our data specialist, is going to be hosting a training session on the new DataStream template. So we released a version 2 this year. So he's going to go through a training session on how to use that if you're interested in uploading data to DataStream. As well, on November 26th, our next Dive into Data webinar series is going to be QA/QC for water quality data, and that's going to be hosted by Dr. Megan Thompson, who's our science advisor, and myself. So you will see me again. And there will be more webinars in the future, so please stay tuned. And then I think one more thing we wanted to let you know is that we do office hours. So the first Wednesday of every month, we have DataStream open office hours on Zoom. We'll all be there, the whole DataStream team. If you want to ask us questions about DataStream functions or any data management practices, we're there to help. So you can access the registry for that via this link as well. Yeah, thank you guys very much for tuning in, and I'm happy to answer any questions now if anyone has anything about the material. I know that we've gone a bit over time, so please feel free to sign off. And if you want to stick around for questions, I'm happy to do so. So thanks.